So, hello and welcome to another Arduino tutorial. In this case, we are going to look at the ultrasonic sensor and how we could program it. And it's actually continuing from what we were doing earlier on, and how we could use this ultrasonic sensor to measure a distance and to find out if there's item inside a container or hopper. So let me just type in paint. And so the idea is this. We have, let me just do big. So we got some sort of container. So forgive me for my drawing. So I'm trying to draw using my mouse. Oh God, that's awful, but it does the job. So there is my container. So some sort of container. On top of this container, we are going to place, that's the idea, this sensor, okay? So I'm going to explain you how the sensor works. The sensor, what it does is it sends a signal out. It sends an ultrasonic sound wave. And what it does is it's when it hits this surface, it bounces back, okay? So we got two sensors, and that's why we have two sensors. One is called trigger. The other one is an echo. So one will send the signal out, and the other one will receive the signal in and will listen. So one side will send the signal out, the other side will receive. Okay. So let's assume, how does it work? It sends a signal out, and it's all about time. Okay. So it sends a signal out, let's say, for example, at 10 milliseconds. Okay. 10 milliseconds. I don't know. 10 microseconds. Okay. Oh my God, I can't even write. Just think of it, microseconds. If, let's say, we are going to, that's what we are going to do. We are going to send a signal for 10 microseconds, and then we are going to listen. How long does that signal takes to come back? And let's say it took, I don't know, whatever seconds. And then what the software does is it will determine the distance. And then let's say this is 100 centimeter. So that's how it works. Okay, so this sensor, what it does is it sends a signal out, it bounces back, and then it says, okay, I send a signal out, and it came back after, I don't know, whatever seconds, and then it says, this must be 100 centimeter. And we will see how we could actually determine that, because there is a proper formula. It's not like a guesswork. But let's say if we put item inside this hopper, then we send a signal out now, and the new signal is in blue. It goes out. This time it hits that surface, wherever it is, and the signal comes back. And of course, now that signal, again, we send, let's say, for 10 seconds or 10 microseconds, a signal out, and we listen back after 10 microseconds, and then it came back. That signal came back really quick, and then it worked it out is 50 centimeter. And that's how it works anyway. So it sends a signal out and it comes back. We use this sensor in many places. One of the places that we could use this sensor, let's say, for example, there we have a door, okay? And there is a door, and there's a person standing outside. And what happens is, most of the time, these sensors will be placed on top of the door. And what they do normally is they will send a signal out to the floor, and the other side, it receives it back. If this person, and let's say, for example, this signal came back, I don't know, in 5 microseconds. And then if the person actually comes and stands in front of the signal, and what this sensor does normally, it sends a signal out. This time it hits the person, it comes back, and guess what? It's much shorter. It means what? There must be someone in there, and that's how this door will open. So they use this sensor in lots of places, okay? And so what we are going to do is we are going to see how we could program this sensor for our use. In our case, our use is this container. Okay, so I'm using Tinkercad, and we were using earlier on Tinkercad to do my simulation, but eventually I'll show you this in real Arduino board. I'm also using, instead of Arduino IDE, I'm using Visual Code, and my extension of my Visual Code is Platform.io because I think it's fantastic editor. Okay, so let's start programming. I am going to put this side by side so that when I write the program, you could understand why exactly I'm writing this program, these each codes. So the first thing is I need to declare what I have. So I've got a few things. I need to declare these pins, trigger, the echo, and I need to also declare the LED. Okay, because in the program, if we start saying, oh, we are talking to the LED, if we don't declare it, we can't use it. So I'm going to call it int trig. So why trig? I'm giving it a name because of that it says trig there. So I'm just literally copying the same name. Trig is equal to, where am I connecting the trig? The trig is connected to number 4. So I will say equal to 4 semicolon. And that's how we write the program. And then int echo, is all right? Am I using the echo? Yeah, so it's called echo, and the echo is connected to number 3, so equal to number 3 semicolon. And then int LED equal to number 2, so number 2. So my LED, if you follow this orange line, it will be connected to number 2. That's what we are saying. These are 3 tangible objects, guys. Tangible means I can touch them physically, but I'm also going to declare 2 items that are not tangible. What are these 2 items? One is the time. The time that is going to actually travel. So if I say work out the time, I need to actually declare it in here, even though I cannot touch it or I cannot feel it, but I still need to declare. Another one is the distance. Because I wanted to know what's the distance. So the distance will be based on the time that is the signal has traveled. So I need to declare something called int duration, or duration and just semicolon, because this duration is not going to be connected to anything in Arduino, so I don't have to put any pin. Okay, and then int the next one is distance, is all right, because I wanted to know what is the distance and semicolon. Okay, so that was my declaration. For the setup, I'll delete this. For the setup, I need what? Pin mode. Pin mode is a special function. It's a predefined function, and pin mode means it will actually talk to this pin. We are talking to this pin. So the reason we are going to call them right now is we wanted to say number 4, number 3, number 2, what they are. Are they input? Are they output? Right now they are neutral. They are not input, they are not output. So we are declaring them now. We are saying in the setup, this is how we are going to use. Trig, comma, is going to be, this is going to be output, is that right? Outputs, close the bracket, semicolon. Pin mode again, and this time echo, is all right? Echo, comma, is going to be input, because the echo is going to start listening. Why input? Because the Arduino will use this pin number 3 as an input, because the echo is actually listening. And we finish this with semicolon, and then one more, which is pin mode, and then open the bracket, and LED. Now the LED is going to be an output, is that right? And semicolon after the bracket. Okay, and I'm going to also declare one more, or not declare, but in a setup add one more. This is called the serial serial.begin and 9600. So that's the how fast the information is going to come in. So that's my setup for my loop. Now this is the actual program. So everything what we've done so far was all about setting up our system. Okay, we're saying this is input, that's an output, blah blah blah, that's all. Okay, and we are also got something called duration and distance, and we are going to see how we could write a formula for these two in a minute. So the first thing what we want to do is digital, write. What do we want to write? We want to, this is a special function, predefined function. We want to write or read to these pins. Okay, so we want to write, in this case, trig. Okay, trig. So this trig, we wanted to turn it low. Does it make sense? So what we are saying is, whatever it is, switch it off. We want to reset it. It's like a reset button. So if there was some sort of signal previously or whatever, we wanted to switch it off. For how long do we want to switch it off? If you think about a reset button, you need to press it down and maybe hold it for a while. Is that right? So in the same way, we could say delay this, keep it off for 20 microseconds. So it's like physically somebody's pressing it down for 20 seconds to reset this button, this trigger pin. So there's nothing inside. So it's off for 20 seconds. Then what we do is, now, once it's off, we let go after 20 seconds. And then we do the same thing. So digital write, this time to the same pin, the trig pin, trig, but we want to switch it on, high. And we close the bracket with semicolons. So we wanted to turn it on. Why do we want to turn it on? We want to turn it on to send a signal out, because that's what it does. The trig, it always sends a signal out. So now it sends a signal out. But for how long do we want this signal to go out? Is that right? So delay in microseconds. Or maybe we want to send a signal out for, I don't know, 100 microseconds. You see, we actually define in saying for 100 microseconds, it's on. Okay, so that's fairly straightforward. Then what do we want to do? After, we don't want to just keep on sending a signal, because what we wanted to do is we wanted to send a signal out for 100 microseconds, and we want to switch off because we want to allow the echo to start listening that signal, how fast that signal comes back. So we write another digital write. Is that right? It makes sense to write digital write this time to what? To turn it off. So switch it off. Oops, sorry. We can't say just low. It's going to be trig low. Okay. So now we switched it on we kept it on for 100 microseconds, and then we switched it off. That's it. That's very good. Okay, so now the next line of codes is all about the echo, trying to listen. So we reach to that stage now where we are going to start writing about the echo. We are going to say this time duration, because how long is that the duration should be on? Or the echo should start listening for how long? Okay, that's what we want to write. So duration, now duration was declared up here, so we need to always open the bracket sorry, duration, actually we cannot write open a bracket duration, and the spelling have to be right with this, so that's good. Pulse in, now this is a special function. Pulse in is exactly something like this. Digital write, it goes and write to the pin, and pulse in is you will actually start looking for the pulse that coming in. Okay, that's all it's all about. But the pulse in should come into whom? The pulse in should come to the echo, comma high. Okay, let me explain this. Duration is this duration, the one we declared, is equal to pulse in. So we are allowing the pulse in, the information, the pulse to come in to whom? To the echo pin. So we are saying the echo pin is going to be, will switch on and will start listening. Distance. Distance now is equal to what? So now we are writing a formula to work out, once the pulse has come in, we want to work out what is the distance in centimeter. Okay, now this is the tricky part. You might say, well, where did you get this information? Duration, yeah, times, I need to write times, okay, 0. What would that be? 0.034 divided by 2. So I'll explain this in a minute. Where did I get that information? God. Okay, this information came from the internet. So let's say, what's this called? HC. Why don't I type in ultrasonic sensor data sheet? That's it. I don't know. Shall we go into this one? Oh, there you go. This is much better. There is this data sheet for that sensor, and you could see the voltage, trigger, echo, and the ground. So that's the sensor. And somewhere in here, there it is. That's the calculation. And what did I type here? I converted, because this is in meter per second, and so I converted into, actually, because I wanted to measure in centimeter, so that's 0.34 divided by 2. Divided by 2, there you go. It's exactly the same thing. Velocity, in this case, is, I'm just trying to work out the distance, and that's it. So that's where the formula came. Sometimes it's a little bit, and then of course semicolon, don't forget that. So it's important to see actually the data sheet. Okay, what else do we do? So this is it. Our program is almost done. So now we have a program that we send a signal out, we read the signal, we convert that signal into centimeter, but what shall we do with this signal? Yeah, there have to be something. Okay, let's do something, the if statement. If, now remember, if I've got open bracket and close bracket, distance, what shall we say, is greater than, shall we say 50 centimeter, okay, and then we open a curly bracket. Okay, so if the distance is now the distance, we will see this in a minute, and then I could say digital write, LED. Now you could see where the LED is coming, high. So what we are saying is, if you start reading, okay, where is my actually this? If you send a signal, and if it is greater than 50, so if this is somewhere here, yeah, the item is greater than 50, if the distance is greater than 50, then the LED, the light, the bulb will come on. If it is more than 50, so 50 is here, if it's more than 50, it will come on. If it is less than, so which means if the item in this hopper is more than 50, so it's more than half full, then the LED will not come on. So we said LED on, else, now this is it. So we close this bracket, by the way. So that's the curly brackets. Remember that curly bracket is very important for that if statement. If distance is this, yeah, we don't have to put semicolon here, then do this else. Now this is the else statement. Yeah, else we open the bracket, this special bracket, and then digital write is all right. Digital write LED and then low. And we close the bracket. Okay, that's it. So if the item inside the hopper, if it's more than 50, then the LED will come on. If it's less than 50, then the LED will go off. And that's it. So it does all the calculation up to this point, and it's quite simple, isn't it? Very simple. And then there's our if statement. But what I told you earlier on was that we want, if it's less than 50, if the, let's say for example, I want the program then to actually say to the user, please put item inside the hopper. That's what we were working earlier on. Yeah. Right now, all we are saying is if it's the distance is this, then put the light on. If not, then don't put the light on. So let's see if this will work. God, we could actually test this. Actually, I could go in my Visual Code. I could just say this, and it runs this. It compiles it. If there's an issue, it tells me there was no issue with my program. I could copy this. Where is copy? Copy, and bring this into my Tinkercad, which I already have it, by the way. So that's the program and paste and run the program. Now remember, this Tinkercad is online. Okay, so sometimes it doesn't function properly. Let's see. So straight away the light comes on because it's 50. Why? When you click onto this it doesn't matter which point, you get this ball. So right now, because it's more than 50, what happened is greater than 50, what happened? The LED comes on. But if I bring it less than 50, the LED should go off technically. There you go, it's gone off. Because now it's 30. And this is assuming this is like some sort of object. And if I push it back, the LED comes on. And if I push it in, less than 50, the LED goes off. Can you see that? So we could actually, we have programmed, because earlier on we were working on, that was 8 hours ago. Can you believe that, guys? So we were working on this to see if the hopper is, we were looking at if the hopper is, if there's item inside, then and instead of our LED, by the way, guys, so what we need to do is, this is the new one in it, yeah. So what you guys need to do, remember, and instead of the LED coming on, if the item, if it's empty, it should actually prompt the user saying, can you please put item inside the hopper? So what do we need to do? We need to start working on this line of code, really. Everything else is okay, because this part of the program, this part of the code, it's all about one thing. It's all about how this sensor works. And this part of the program is the one which we need to change. Okay. If you remember, I gave you an example. The example I gave you was sometimes we could use this sensor to open a door gate. So everything else will work okay. But here, if the distance comes back less than, let's say, for example, I don't know, 700, because that sensor could actually measure up to, if I'm right, up to 2 meter or something. So 700 centimeter, then open the gate. So in this case, you will send a signal saying to the motor, start the motor opening it. That's all. So for us, we need to change this part of the program. Now, what do we need to do here? Earlier on, what did I do? I added something here, serial begin. And serial begin, if you know the last time which I've explained to you, it's all about one thing, which is serial begin is we wanted to, what does it do? We wanted to measure, or we wanted to read the serial from the serial monitor. So if the distance is this, then what we could do is we could actually say, comma, sorry. So this becomes now what? Comment. And we could actually say, this is, I'm not going to give you the answer, but I'll start off something. Serial, yeah, dot print this time, is that right? Print ln, open the bracket. So what do we want to print? This time we could say, if it's greater, actually in this case, if it's less than 50, okay, enter. I'm actually thinking item inside the hopper, yeah, hopper. Okay, so serial is wrong because this was supposed to be capital letter serial. Okay, else, so in this case, if the distance, I don't know whether this is what you want or not in your program, you guys need to work out. I don't want to give you the answer for your task that you're supposed to do. So if it's less than 50, no, actually, sorry, no, it was right. So if it's greater, so if it's more than not 50, let's say if it's more than 90. So what we are saying is this signal is reading up to that point, so it's coming back. So there's almost empty. Then enter something inside the hopper. Actually, else, let's make this high. And let's see what this program does. So that will be interesting, isn't it? Copy. And this gives you guys a good paste. Okay, so let's look at this. If the distance comes over 90, it gives me this message. If else, the LED is always on. Yeah, so the LED will never come on, yeah, if this is over 90. So serial monitor, so that's the monitor where it writes this information. Let's simulate. Oops, I've got some issues in my program. Let's go and read what is the problem. Semicolon. So that was the issue. Let's simulate. Yeah. So if I click in here, what do we have here? We got over 100. So it says enter inside the hopper. So the LED is not coming on. And when I do that, guess what? It stopped what? The LED comes on, but it stops what? Telling me enter something inside the hopper. Okay, so that was the reason why I put that serial begin. If you don't have the serial begin, by the way, this will never work. So I think almost I've done half an hour and I'll stop. So if it's more than if I push this, what happens? The serial, these things will start saying, oh, hold on a second, oh, the thing is empty inside and you need to enter something. It's giving. Now this is still on. That's because of the internet. Okay, remember this program is based on the internet. So sometimes you have this glitch, but it doesn't mean this is not working. It could actually be my program as well. Maybe. I don't want to say anything much. Okay. So here I'm going to stop. So I hope you learned something. So now you'll be able to do the stuff that I gave you to do. Okay. And also find out if actually I was supposed to do something here. Okay, maybe. So we verify everything is good. We got one problem. Somehow again I deleted that because I saw a red line there. Okay, so that red line is gone, so everything is successful. Yeah, this is the program for thing. Okay, thank you very much.